Hello geometry students, it is Miss Graham here and we are looking at lesson 6 today. So we are building off of what we saw in our last lesson, lesson 5, focusing on volume, but now we're going to be focusing on the volume of pyramids and cones instead of looking at prisms and cylinders. We are going to see some similarities, but we are also going to see a couple of differences as we work through each of the problems. So let's go ahead and start off with looking at the formulas for pyramids and cones. You can see below in the pictures that I added some extra visuals for you to look at. For our pyramid, I wanted to really re-emphasize that there technically is a right triangle here. We have this vertical height that creates a perpendicular relationship, a 90-degree angle, and we also have this slant height. It goes against the face of this triangle off to the side. So this idea is what we're going to be building off of to help us find volume. And you can see with a cone, we also did the same. We created that vertical height that has a perpendicular relationship, and we're also talking about kind of this slant height to create this triangle. Both of those are going to be really helpful for us when we're coming up with the formulas. So let's go ahead and start looking at our pyramid. So to find the volume of a pyramid is actually going to be 1/3 times b times h. So it's a little bit different from our other two shapes of prisms and cylinders. It's not just b times h, it's going to be 1/3 of that. So keep in mind that b is going to represent, right, the base area here. So looking at a cone, figuring out the volume formula for that is actually the same thing, 1/3 times b times h. So again, we're going to be looking at b as the area of our base here. So let's go ahead and look down below at some examples where we're going to incorporate these two formulas into it. So let's look at number 1. So we can see there are two questions, A and B. We're going to try doing A together, and then I'm going to have you try B on your own. So looking at this, I can see that I have a rectangular pyramid, and I'm given the following measures. I also wanted to point out that I included that vertical perpendicular height just for a visual. So looking at this, we want to label our length of 6, our width of 10, and our height is 3. So this height right here, we can label that as 3. Technically, I could say 3 centimeters. Now, it doesn't matter on either of these sides here. One of them will be 6, one of them will be 10. So I'll say, let's take the front one and make that 10 centimeters, and the side one and make that 6 centimeters. So to find the area of this base, remember it's a rectangle, we're just going to take 10 times 6. So that will give us the area of our base. So that's represented by B, so that will be 60. Now looking at the volume, how to incorporate that formula. Ready? It's volume equals 1/3 times B times H. So remember, B is the area of our base of 60, and H is our height of 3. So when we put this in our calculator, we end up getting 60 centimeters cubed as our volume for our rectangular pyramid. So here's what I'm going to have you do now. I want you to go ahead and try example B. I already started to kind of help you out by drawing that height in. So go ahead and pause the video and we'll check our answer shortly. All right, looking at our problem right here, I was able to label each of the lengths, widths, and heights. I was able to find the base area of multiplying my width times my length. And then I took that amount and I plugged it into my formula for volume. And I ended up getting the decimal of 147.25 inches cubed. So that's a little bit of practice working with rectangular pyramids. So now let's go ahead and start looking at example 2. Again, there's a part A and B where we're now going to be looking at cones. So we're going to do part A together, and then I'm going to have you try part B. So focusing on this, we want to find the volume of a cone. So keep in mind that's going to be our base area, so our circle area, times our height. So again, I incorporated the dotted lines into the picture to kind of figure that out. So if we're given the radius of 4, I can actually label that on my picture here. If I've been given the height of 8, I can also label that on my picture. Now keep in mind, to find the area of our circle, right, to find b, that area, it's pi r squared. So I essentially have pi times 4 squared. So all in all, I have 16 pi. That's what I'm going to be substituting into my equation for volume. So remember, volume is 1/3 b times h. So my b is 16 pi, so it's times 1/3, and it's times my height of 8. Again, we can keep this an exact number. We can find the decimal. I just kept it as exact using pi. So I got 128/3 pi. So I kept it as that fraction to just be more exact because, 128 wasn't divided evenly by 3. So keep in mind that our units are going to be cubed because it's 3D, so we have centimeters cubed. All right, it's your turn now. You're going to go ahead and try this problem. Keep in mind we're given the diameter, not the radius, so don't get tricked. Go ahead and pause the video and play it whenever you are ready. All right, going over this example, we can see our diameter is 12, so half of it is 6. The height is 9. So to find the area of our base, it's pi times 6 squared. So it's 36 pi. Put that in our formula, so we have 1/3 times 36 pi times 9. And lo and behold, we will get 108 pi centimeters cubed. All right, one page down, one more to go. So we just finished page 14. Now let's move on to page 15. So we are on page 15 right now. We are going to look at problem number 3, where it is asking for the exact volume of our pyramid and cone. So this is a really good opportunity for you to actually try out these two problems yourself. So again, I emphasize that we are looking for the exact volume, so you can leave your answers in terms of pi if needed, or you want to make sure that you're leaving them if it's a decimal, that it's a decimal that stops, or maybe you need to leave it in a fraction form, because a fraction form is a little bit more exact than a decimal needing to be rounded. So go ahead, test your knowledge on A and B, pause the video, and then we can go over what volumes you should get for each shape. All right, looking at example A, again, we're looking at a cone. So we have to find the area of the base first, which is a circle. So that's pi r squared. So really we have pi times 5 squared. So that's 25 pi. And then we take that amount, plug it in for B into our formula of volume, have our h of 13, right? That's our height. Multiply that all together. And unfortunately, it doesn't really give a nice decimal. So I kept it as a fraction. So that way I have 325 divided by 3 pi, and that's centimeters cubed. Now part B, I honestly think is a little bit easier because we just have to find the area of our base, which is our rectangle, right? That's one side times the other. So that area is 56. Plugging that back into the formula, we multiply it times height times 1/3. And lo and behold, we will end up getting, again, it's going to be a fraction, but it'll be 616/3. And that's centimeters cubed. Now, it's good to practice this idea because we're now going to look at number 4, and we're probably going to review a topic that we've seen probably in almost every single lesson, or it seems like every single lesson this semester. So let's start looking at number 4 and talking about that. So we want to find the volume of our right triangular pyramid, so it's a triangle, with height 15. So maybe I should start off labeling that 15 for that height. And wait a minute. In order to find the area of this triangle, right, I need the base times the height and take half of that. So essentially, this triangle, if I redrew it, right, I'm essentially looking for this missing side. Now, it doesn't matter if we have, 5 on the missing side as our base, as our height. Doesn't matter how we draw it. But kind of here's how I constructed it. Kind of turned it, made it a little vertical to show it's a right triangle. I have my hypotenuse of 13, my leg of 5, so you know what that means. Good old Pythag. So our a squared plus b squared equals c squared. Plugging in 5 and 13 to the correct spots, working it on out, you actually should get a Pythagorean triple number. So that side is going to be 12. So now, again, for our volume formula, it's 1/3 times b times h. Remember, b is the area. So wait a minute, we have to find the area of that bad boy right there, right? The base area is 1/2 times one side times the other, right? 12 times 5, right? Base and height. So we get 30 there. So now when we're plugging it back into our formula, we have 1/3 times 30 times our height of 15. So when we put that all together, we get 150 meters cubed as the volume of our right triangular pyramid. So this one actually wasn't so bad. Wasn't so bad to do. Now, I will tell you, number 5, the last one, will probably be our toughest. And I actually do want you to try a little bit at it on your own. So keep in mind, it's asking for the volume of a regular right hexagonal pyramid. It's shown with side lengths of 12, so each of these side lengths is 12, so we can label that. And we can see that I added this vertical height here just to show you that height is actually going to be 15 centimeters. So I'm going to go ahead and label that on there. So you have that as a visual. Now keep in mind, they also give us another picture here. I will tell you each of these sides will also be 12. So I'll kind of give you that as a little bit of a start, but see if you can remember what we've kind of been learning about the past couple of lessons. You know, see if we can figure out and remember how to find the area of a hexagon and then be able to apply it to our formula. So pause the video right here, see if you can try to figure it out, and we will talk it over together. All right, had a little bit of time to work on this, so just giving you a heads up, we gotta break up this hexagon into right triangles. So you have to think about, okay, we have these big right triangles. We're essentially creating 6 of them. So together, these are 60 degrees, right? Each of that angle is. So we're really taking 360 divided by 6, that's 60. So that's the angle measurement if I put 2 of these triangles together. So half of that, right, half of 60 is going to be our 30, which is what we're looking at. So keep in mind, right? This is our 30, 60, 90 triangle. So we know we have our short leg. We know we have our short leg times 2, and we know we have our short leg times root 3. We know our short leg, it's half of 12, so it's 6. So that means our long leg, which is our short leg times root 3, will be 6 root 3. So now finding the area of that, right, the area of that base is 1/2 a times p. Remember, a is our apothem, right? It's essentially our short leg root 3. So I can plug in 6 root 3 for a. And our parameter is taking all of these sides and adding them together. So it's 12 plus 12 plus 12. It's essentially 12 times 6. So that's where I get my 72 from. Putting that in our calculator. Again, I'm going to keep it in radical form just for more exactness and not rounding mid-problem. But we get 216 square root of 3. Now, all of that work just gives us the area of our hexagon. Remember, we have to take the area of that base and multiply it times the height. So we're essentially taking 216 square root of 3 and multiplying it by 15. So writing down our original formula, right? We're going to multiply those, but don't forget, specifically, right? When looking at pyramids and cones, we also multiply by 1/3. So I have 1/3 times 216 root 3 times 15. Again, multiplying that out, I'm going to keep it in exact form. So with my radical, I end up getting, and this is a big one, 1,080 square root of 3. And that's centimeters cubed. So, big problem today, wasn't that? Well, nice job. You covered the volume of pyramids and cones. Now, we already did prisms and cylinders. So our next lesson that we're going to be looking at shortly is going to be focusing on density. And then, later on, we're going to look at the volume of spheres. So, have a good rest of the day, and I will see you later.